Hello, everybody. Welcome to our webinar, Introduction to Kubernetes as a Service on CREODIAS WAW3-1 Cloud. We're very excited that we can share this knowledge with you, and I see lots of people are here, so welcome, everybody. Our presenter today is Paweł Turkowski. He's our product manager responsible for Kubernetes as a service. And Paweł will do a live demo of the Kubernetes on WAW3-1. So let's keep fingers crossed because live demo is always tricky. And there may be some unforeseen things happen, but let's hope for the best. Paweł?
Okay. Hello, everyone. It's a pleasure to be going through this webinar with you. So maybe before we start, just two remarks from my side. So there is a mixed audience here. Some people are more technical, some people are less technical. We try to balance the content, so it's relatively interesting for everyone. And then another remark that I have is that during the demo we'll be presenting, putting some services or clusters, and sometimes it takes a bit of time for these things to happen. So we have a fixed agenda, but we will be also sometimes going forward or maybe skipping certain things, depending on the speed of the flow. So the agenda for today is, first of all, a quick introduction to Kubernetes. We'll deploy a Kubernetes cluster on WAW3-1 cloud. So we'll show how it's done. Simple introduction to the tooling for managing the cluster, so that we can access it and manage several clusters maybe at the same time. We'll show deploying some sample applications on pods. We will also talk about scaling your deployment, also including auto-scaling. And towards the end, I will show an application that might be interesting because quite a lot of people on the audience are dealing with the IO processing. So that might be a workflow that might be something worthwhile for you. Okay, so starting with the introduction to Kubernetes, basically it links to the topic of containers, which likely most of you are familiar with. So I'll just recap. Traditionally, the deployments are happening on the hardware and the fixed operating system, and there are two sets of people responsible. There are developers writing these applications, and there are admin people who are taking care of the systems below, and not always that works great, and that's why the advancement from this was to move to the virtualized deployments with the virtual machines, and then the next step of this evolution is the containers. So you might have heard a lot about Docker, and this is basically we have a container runtime on top of the operating system that is basically independent of the platform below, so that the containers can run and can be deployed to various environments by basically the same person. So it also helps to take ownership of the development to the people dealing with the development from start to end. And then on top of the containers, the challenge is that as the application grows, as the requirements grow, the number of containers grow, there is also a need to manage all these containers running in parallel. And that's where Kubernetes comes into play. And that helps with basically scaling the application and automatizes a lot of tasks that would normally be needed to be performed by an operator. It takes care of things like healing the cluster and managing if some containers cease to exist, they are replaced automatically with new ones. If the load increases, there is also another set of containers automatically deployed on pods. So a couple of concepts here. So basically, we deploy a Kubernetes cluster, and this cluster, in simple terms, consists of two main. Well, the instances are either nodes or the workers or masters, and it's also referred as the control plane. So the master is in charge of managing the Kubernetes, the infrastructure behind the cluster, and the nodes are workers that are running pods within them. And in a pod, there can be either one container or there can be more containers, and then they are also using volumes because of course the persistence of the storage is important there. What we will refer quite a lot today is about pods, and pods could be deployed by themselves, but usually they are deployed as part of a deployment or let's say a job. In some other cases that manages also replication aspect. So if one container is destroyed, the deployment takes care of automatically replacing it, and so on. And then the concept of service is more a networking service. So while the deployment is available on the cluster, the service takes care of, for example, exposing it to the broader public, let's say to the internet, for example. And then one very powerful concept of Kubernetes is the Kubernetes API, so that the cluster is something that can be basically operated from the outside, let's say using some external libraries of different programming languages, and it can be that's a lot of power of this, that it's not really fixed to the Linux console and deploying the things from inside, but also can be the pods, the jobs, the auto-scaling, all of this can be happening even by people that have no real knowledge of Kubernetes, if it's abstracted on some user interface, for example. Okay, so this is a very brief introduction, and I realize the topic is broad, but we have some time constraints. So I will jump right into deploying a Kubernetes cluster on WA3-1 cloud. Okay. And just maybe a notice, you see me showing the regular presentation, but I will be also showing the presentation on my laptop, just for simplicity's sake, because I will be jumping from the Linux console to the presentation. First of all, we'll go to the Horizon interface. So I'm already in my project from WA3-1, and you see we have the button here, container infrastructure. So from here you create a cluster. There is also another tab called cluster templates. This is, let's say, for more advanced use. We normally recommend using the standard default cluster template, so you would not need to go through the cluster templates. And for this advanced use cases, it might be even that you prefer to use the CLI, which I'll just briefly touch upon in a moment. So we'll right away create a cluster on the WA3-1 cloud. So I'll call it sample 1. I'll choose the standard template that is there, the recommended one. We just have a one choice here of Nova. I have already a keeper, so normally you set it up in any case if you want to run instances. So my keeper is here. Here we have something that is very unique to our cloud, because we, as a CloudFerro, we have access to the EO data. So each of the pods also will be able to access this EO data if we check this box. So EO data access enabled for many people dealing with EO operations will be very useful. Okay. I'll set up a very simple cluster that will just have a one master node. It will have a one worker node, but we'll choose the option of auto-scaling the workers, so that when we present the autoscaler, we will be also able to have the scaling on the node level. There are two types of scaling: on the node level and on the pod level. We'll mostly focus on the scaling on the pod level. Depending on how the application behaves today, it might also scale on the nodes. We'll see. Okay. If I have just one master node, I will not click this enable load balancer. Normally, if you are putting more masters, please click this this button so that you can create your cluster successfully. And then I will also choose create a new network. Normally, you also have some other options here, but this is not recommended to use these settings unless you know what you're doing, and you would need to set up the network first, and then add it here from the list. Okay, I will not choose the access on the public internet. This cluster API is basically if I want to access individual nodes or individual masters, then I would choose the public. But in most of the cases, this is not needed. This might be needed for some troubleshooting or some special cases. Kubernetes takes care of all of this, so you don't need to access the nodes directly. You're interacting with the Kubernetes API. Ingress Controller is something that we added just recently. I will not focus on this in this demo, maybe for some future demos. We do have an Nginx Ingress Controller if you are interested. Okay. Normally, we will choose auto-healing enabled so that it takes care of the healing the unhealthy nodes if something happens. For the labels, I'm leaving this blank. There is one setting that I'm put in the presentation. If you, let's say, want to run a larger cluster, then you might need to exchange your network mask. And there is in PowerPoint, there is the example. There are also many other different labels that you could use. You would need to refer to our documentation or also the Magnum documentation. Because what maybe I have not noticed, not mentioned, as all of our services, also the Kubernetes platform is based on the OpenStack platform. So OpenStack Magnum project is the reference for our implementation. It's of course open source. Okay, so I did deploy the cluster. It's running here in the background. So normally it will take around 10 minutes to create such a cluster. So I will not wait. I will use an existing cluster to show you other things. But in the meantime, so we went through this sequence of steps here of doing it from the horizon. One thing that I will be doing, and you will need to set it up for your project, is of course you will need to have a project created on WA3-1 Cloud. You will need to have a base machine with a Linux terminal. I'm here using my Windows with Linux embedded. And on this base machine, what I have is I have Python installed, I have pip, and I have an OpenStack CLI client installed. So we have instructions for doing these operations on our CREODIAS platform. You can refer to that. And then also the RC file needs to be downloaded from Horizon and sourced on the base machine. This is basically for authorizing with the OpenStack client. These are the steps that I mentioned. It's a couple of comments, so you can have a reference to that in the presentation. These steps we went through, so I'll skip through them. Here I put the instruction for the larger clusters. I will not go through this one, but this is also well documented in our documentation. You can also perform the operations of deploying a cluster from the CLI if you have some specific requirements or a workflow, or you want to do it automatically from some other piece of software. You can do that. Now the tooling for cluster management, and so these steps I also have already on my machine. Basically, there are two things. There is the Magnum CLI and there is the kubectl. And with this couple of comments, you apply these things. And then you have an OpenStack COE comment that basically takes care of many operations in your on the whole cluster level. So you can, for example, list many different clusters. And then kubectl is already referring to a specific cluster. So you point to a specific cluster and let's say you deploy pods or jobs and so on. So that's the distinction between the two. What also needs to happen on the cluster is you need to install the config so that it points to the right cluster. So if you have multiple clusters in parallel, then you would always do this operation of exporting the kube config so that it points to the cluster that you want to be working with. You can also specify multiple configs, and then you can just point to the config file from your comment, so that it's a bit simplified, but I'm not using it here. And then also the optional thing that I think I will skip through, I will just show it on visually, is the access to the Kubernetes dashboard. It's a interesting thing because it enables you in a visual form, and it's built into Kubernetes. It's nothing that you need to develop or do anything with it. You just have access to all the information about your pods, jobs, nodes, and everything. So that's an instruction. It's a bit more involved than the previous steps, but it's a couple of comments. So it's quite doable. Okay. Here I'm referring to some useful kubectl and Magnum CLI comments. Usually this is very intuitive. So you have a get for getting a specific resource, and then you can delete specific resources, or you can maybe describe them. So go and get more information. So the API is very consistent. Maybe what I will do is okay. So with this comment, you see all the different types of resources that are available. So for example, you have here jobs, or you have pods, or nodes, and for each of them, you would usually use the kubectl to either list them or get more information about the specific resource, so that you need to then specify its name, and then you get this information. Magnum CLI, it's also useful. I mean, some of the things you can see also from the horizon, but this extends the possibilities. So if I do I have a challenge with my scrolling here. But yeah, here you will see the clusters that I currently have, and this is the sample it's still creating. So okay, let's go farther. So now that we have a cluster, we want to deploy some pods to this cluster. So we want to deploy some application and see how it can be done. What I was referring to before, and yes, maybe I'll just, oh, this slide is hidden. It's interesting. Okay. So you have a Kubernetes cluster, and this Kubernetes cluster needs to get some Docker images to work with. So usually you would have a registry that will you will be pulling your images from, and you can have either a private repository, or there are multiple providers that offer this. I will be using, for the purpose of the demo, the Docker Hub, which is quite a popular one. Yeah. So normally you would, how you would deploy pods? You could deploy the pods, as I mentioned earlier, individually, and then you pull an image of the container, and then the pod is created with this image of the container. But normally you would use a deployment for that. It's a one-line comment to basically deploy such a pod with such a deployment with containerized application, where you point to the image in the Docker Hub, and then what I was referring to earlier was about after you create this deployment, you want to also expose it. So that will make it available. If you, for example, use the type load balancer, it will be available on a specific IP address and accessible from the outside as well. But normally, how all these deployments works is that you rarely deploy the pods maybe for very simple use. You would deploy it from the command line, but normally you use YAML files that specify that specify the spec of these pods that are inside the deployment, and then specify several different attributes, and the list can be either very long or it can be very short. It depends on your need. This is a sample from maybe a bit simpler application than I will be deploying right now, but a very similar one. The application that I will deploy is a very simple app that basically takes the images from our EO data and shows them on a web page. And for the purpose of this, I'm also using some non-persistent volumes so that it pulls the data from the S3, it caches it locally on the pod, so that the pod can have instant access to these images. And then also the app, what it's doing is, you will see later in the demo that it's simulating quite a high load with some artificial loop there. So it's working slower than normally an app would. But let's, without further ado, create. Also for the comment, I would like to make these applications available for you so that you can also utilize. So I will put this in some GitHub repository that we can that you can access. Okay, so I have here this application, EO Web App, and here maybe I'll just very quickly present this. As you see here, so I'm doing this heavy loop, and I'm listing the images, and then I have a, you see, I have a Docker file. So for this is already deployed on my Docker Hub, so on my repository. So you can see the EO Web App is the one image that I have. I already pre-built it from my Docker file, and another one is the EO Web App init that is here. And similar, it's application that pulls the images from the EO data, and here you can see I don't have to use any credentials, so any pod is automatically with this EO data checkbox applied. You have basically access to the EO data. Okay. So without further ado, I will this EO Web App deployment. Okay, so now we can see there is the deployment created and also service. So this is a very similar example that I was showing here. So you have a deployment with its spec. For the containers, you see here I'm using the limits and requests for the resource. So this is important to add these limits and requests in order to have your auto-scaling working. And then I'm also using a volume mount that on one side, this pod access, and it will be shared with the container that is pulling the images. So they are both sharing the same volume, and this volume here is non-persistent. So it's after the pod disappears, also the data will be gone. So that's for more simpler use cases, and normally you would like to persist this data. So let's see. I will just clear so that it's nice and clear. Maybe what we can do is also we can show our nodes. So we have two nodes. We have master node and the worker node. And then let's see our services and the deployments. So we have our EO web app deployment that is there. And then we can see if our services are there. And so you see the service is also created. It's pending, so it will take a bit of time before the floating IP will be assigned to this service. Maybe instead of let's see, maybe it's already there. It's already there. Usually it's maybe 2 or 3 minutes where it's available, because behind the scenes it creates also a load balancer. It's an actual load balancer that is there, that is created. I'm using this here for many of the examples that for each of the service I'm applying a load balancer, and the ingress function that I was referring to earlier. This is something that will help to limit the number of the load balancers and then share this load balancer between different applications. But this one I will not be talking about today. Okay, so let's see if our app is available already. So this is a public IP address. Normally each of you should be able to also access this IP address. So indeed it works. If I refresh the page, then these images will be rotated. That's how it is designed, that it basically gets some random images from this collection. Okay, so that's our app that is deployed. And now what I will do is I will deploy another pod also and expose it as a service. Okay, so I have here another app that is basically a load testing app. It's used for load testing, but here we will use it in a bit of a different context. We will use it to simulate the load on this application that I just deployed. Okay. So this is a very simple deployment. It's just because it's a third-party application. So here, what I'm just doing is I'm basically pulling it, and then I'm specifying a couple of details in the so that it's so that I can expose it from my own endpoint. Okay, so I'll apply this YAML file that will create both the deployment and the service. Okay, so they are all both there. And as previously, that will take a bit of time before it's done. So I have 2 minutes probably that I have to talk about something. So I will go into the scaling. So normally you can scale the application either manually, and then we can maybe even try to scale this application, the IO web app. So scale deployment. One important thing that I missed is also what you usually use is kubectl, of course, get pods. So you want to see what are the different pods. So for now, each deployment is basically represented by one pod, because that's how we specify, just one replica. But here now, for example, I want to load balance this this application. So I'll do I think I'm, and then I'll specify replicas, and let's just do 3 replicas. Okay. And I'll clear the screen because dump. Okay, so you see I have one pod that was already there, that's running, and the other 2 are in this initializing stage. So there is a init container that is just running, and when it finishes, also the other 2 will become available. It's still running. I think I'm having a 10 or 15 seconds there waiting time for them to finish, on top of doing their own job. Okay. So they are already running. So you see, this is this method of basically manually scaling, and you can apply this method. I will go back and I will just scale it back to just one pod. Just one replica. Let's see. Let's see now if we already have the service for the locus deployments. Okay. So yes, so the locus deployment is there. Okay. So this is this other application that is there. So we have our application, and then we have another application that will be stress testing this application. So I'll do here. So I'll specify the address of the target application, and then I will let's say I'll start running it with this tool basically simulates the amount of users. So I will start with 100 users that will be accessing this app, and then every 10 or 15 seconds, I think it's in the spec of this locus, there will be 3 users changing. So so that's what I will do. But before I do that, I want to check one thing. Okay, so I already have only one pod, so this is good. So let's start stressing this application. Okay, so here you see this is the amount of requests. This is oh, I think I did something wrong. Just one moment. I think I swapped the number of users to the number of changes in users. Ah, yes, of course. So yes, there will be 100 users, and then there will be the users started per second will be 3. So that's the correct way of doing it. Okay. So on the bottom chart, you see the number of users gradually increasing. Okay, and our application response time also goes up. So it's putting some pressure on our application, and yeah, the number of seconds that the user needs to wait is basically increasing. So this is not good. Maybe we can also observe this from here. I'll also remark that I've been running this test a couple of times, and not always it's very predictable because there are some delays. So also on how the API reacts, and for such a short period of time for the demo, it might not be showing this precisely. But you see already here, it's a bit longer that one needs to wait for the refresh time. So what I want to do is I want to, let's maybe even stress this application even further. So let's say I'll do 250 users and then 5 users. So it goes up, and then normally the better thing to look on is this green line. But you see already the number of seconds that the user will need to wait is becoming more challenging. So what I will do, I will ask my deployment to scale automatically. That it will define by itself, by the amount of the resources that each pod needs, which I specified in the spec, how many pods should be running there. And then I will specify minimum 1 pod, let's say maximum 20 pods. I think we will not reach 20 pods today because I also want to show some other things, but this is auto-scaled right now. And it will take a bit of time for this to materialize. So the scale on this chart is a bit right now becoming blurred because of this 95th percentile there, so that it's not very evident to see, you know, how this value changes. But if I go, let's see, there's already new pods joining the deployment, so that they will be helping with reducing this load. And I'm afraid, you know, you will not see it right away. There might be some aspect of the and usually this is faster, what I noticed, than even the this status is here, so that the pods are already becoming available faster than they are there. But yeah, you see the other pods started to run, and then also the response times have decreased. I will stop here because we still have a couple of topics to discuss. Normally, and this is what will happen and works out of the box if you check the also the node scaler, is that if you run out of the pods on a specific node, then right now I only have a one node, but I've specified that it will scale to 2. And of course, you can be working on a much larger scale than that. But at a certain load, if I start pushing more load to this application, there will be another node basically added, and then if I had more, then more of these nodes will be added. Just out of curiosity. Yeah, so you see other pods are already joining the crowd so that they will be helping to scale this application. Okay. I will leave this running like that. And maybe I'll just do one more thing and just go crazy and scale it to, let's say, 500 or let's say 1,000. And 20. Something is not right to see why. And let it just run, but I will not focus on this part anymore. Maybe we'll get back there later and see if it's if the node is added or not. But I can guarantee you it will be added. Okay, let's move on. This is one of the last parts that I want to talk, but in my view, it's a super interesting aspect of Kubernetes and how you can use it. I will show it on a sample EO processing workflow that I could imagine as a EO processing workflow. I'm not working with these things on a daily basis, but the purpose here is to present the Kubernetes, how it can deal with that. I will not be, by the way, yes, our sample cluster. So this is the cluster that I started at the beginning of the demo, so it's already created. It was probably created already several minutes ago. But let's not focus on this now. So I have another cluster. I will not be already deploying these applications for the sake of time, but I will go to my other cluster that I have. And that, as I was mentioning, you need to point to the another cluster with a new config. And here I'm pointing to the directory on my local drive. I think it's like that. This is a config file. Okay, it works. Just check. Yes, it works. I'll start from this slide, and that might not be perfectly visible, but this is an application that consists of 3 containers, and one of them is Postgres container. That is a persistent storage. So I'm using one container for just having a database running on it. I have a container for processing jobs. So there will be jobs deployed in parallel. This container is getting data from the S3 storage, and it's also saving it back after processing, which I'm not doing here. So I could have probably written a couple of Python lines to simulate that, but for now it's just taking the same image and it's storing it in my private bucket. And then the third is the web interface container that is just showing these things in action. And a couple of things that you might want to refer back maybe after the demo, just in the slides, is using quite a few of these concepts that are interesting. So we have Kubernetes jobs. In order for the web interface to authenticate with the API, I needed to create a cluster role for reading the jobs and reading the pods, and then also the cluster role binding, so that this role is bound to the it's correctly bound. And on the persistent volume side, so we have a concept of persistent volume claims, so that there is an ask for a specific amount of volume, and then a persistent volume is created. It's an actual volume that is created behind. So if you look here in my volumes, I have my persistent volume claim here, created by the OpenStack Cinder CSI driver, and this is already running. So I'm not deploying it from the scratch; it's already running. Also, so the Postgres container is deployed and it's running and it has its endpoint. If you look at the pods that I have a Postgres container that is running. I have some sample containers here that are not in scope of this demo, but this container is running. Then for the web interface, I do have all the YAML file and the deployment, but I've already decided I would rather show it for the speed purpose from my local host. And this container will be creating other pods, will be pushing the job to create other jobs. So I think I've talked maybe a lot, but I will show this to you in action. So let's do the following. Okay, so here I will just run it locally. One of the three containers I will run locally. And this is the web application. So I go to localhost. Okay, and here we have our application with a sample processing workflow, and it's a super simple setup here. So I have deploy the processing jobs, manage current jobs, and then job history. So the job history is taken from the Postgres database. Managing the current jobs. Currently, there are no jobs, and this is also if I access from the kubectl, it will show exactly the same thing. But okay, let's deploy some jobs so that we have some. This part is absolutely mocked, so these values are totally fake. I will just focus on the two elements. Let's say I have a collection from some date X to date Y, and I'm using some processing algorithm which I'm not using, but I will deploy a couple of jobs so that if I have, let's say, I don't know, 150 files. I don't want to do it just on one process because there might be a very heavy process behind. I want to distribute it, and maybe even let's load it more, so it takes a bit more time. Okay, so I run this batch, and then you see the jobs are populated, and this is the part that I'm particularly excited about, is that you don't need to any more than use the Linux interface. You can basically, after this, I'm using here the Python client for Kubernetes, and that maybe I'll just quickly show. No, I will not show because it's running. Maybe I should have run detached, but it's okay. So I will not show this right now, but I will show last part in the docs. You can have access to this client. So the jobs are active; they are not completed. Let's refresh and let's see. Not completed yet, still running. And then, as I mentioned in this chart, this is pulling to my private storage. So if all goes well, I should be able to see. Okay, so nice. Some of the files are already popping up. And let's see here. Okay, all of my jobs are finished. So as you can see, I was able to talk to the Kubernetes API from this application, and you could also see here that there are these jobs there, and then I could delete them from the Linux, but I will just delete them from here. Okay, let's. Okay, and there are no jobs. And there are no jobs here. Okay, so with this, I would say that this is, maybe I just show one last thing. Also, our Postgres is doing its work. So yeah, this I already have quite a lot of history here of my test jobs, but these jobs of 300, the 5 jobs of the size 300 files were added here. Okay, so I would say this is this covers the part of the demo. I think we're right in time, and with this one, I will switch probably and just wrap up, right? So okay, maybe one last thing that I want to say is we've put in this documentation the useful links. So you have our CloudFerro Kubernetes documentation. You have the also useful, especially for some more advanced use cases, the OpenStack Magnum documentation to refer to. And then all the Kubernetes resources. This is a key reference, basically, and then also the Kubernetes API reference that I was showing before, and the Python client. So I would like to ask, thank you very much for your attention.
And now let's do a Q&A. So the first question was, will CloudFerro also run a container registry for users like Harbor or Quaya? And the data could be stored in OpenStack Cinder S3 quota. And I think we have on our roadmap that in the next month we'll add pre-configured applications that you can deploy on the cluster, and one of those will be Harbor. And if this isn't enough, so you will need something more. For example, the Harbor maintained by us. Please reach out to us. We are developing this Kubernetes as a service solution on a daily basis, and we are adding more features. So we'll put it probably in our roadmap. The second question was, is the Kubernetes load balancer service using OpenStack load balancer? It's an OpenStack router used to allow traffic into the cluster. It's OpenStack load balancer, the standard Octavia load balancer, but on the WA3-1, currently it is using the default configuration of load balancer. We are working on adding more configuration. So when deploying the cluster, you'll be able to choose if you want a very small load balancer, because, for example, you're testing something and you don't need a high availability load balancer and just something very small and very cheap, or that you need the more powerful because there's lots of traffic going through the load balancer. So yes, it is using OpenStack load balancer, and there will be new features in the coming months there. What are your experience scaling? The next question, sorry. What are your experience scaling to the Kubernetes cluster, to example, 500 nodes? I understand that currently large clusters become unstable. Is that still the case? Yeah, we know that building a large cluster is tricky. One thing is that deploying, for example, 500 VMs simultaneously, it's not that easy, because we have some OpenStack limitations there, and the performance is not always there. For example, if too many people just start deploying that many VMs at once, because the deployment doesn't wait long enough for VMs to spawn, and the underlying management interface is not fast enough. But we're doing lots of testing here, and we're searching what is the optimal and what is the maximum configuration we support, what is the maximum node number of nodes in cluster, how to get there. So, for example, not at once, but in the batches of 50 or 100 nodes at once, and how many workers you can work in nodes you can have in node group, because this is also a limitation of the OpenStack. The next question. In the cluster configuration, you have one master and one worker node. Well, yeah, if you scale the cluster, does it create additional workers nodes as the E1 large instance? The new nodes, if you auto-scale the new nodes, will be, if you don't specify, yes, they will be AO1 large, but you can also use different nodes and different sizes, but there is some configuration required, so this gets
you need to
harder.
apply another node group and with different setting, and then they will work and be scaled as well.
Okay, and the last question was, how can you use Cinder to create persistent volumes from within the Kubernetes? So the Magnum automatically provisions OpenStack Cloud Controller, which allows you to create persistent volumes with Cinder. So the template that is deployed has this feature just inside of it, so you don't have to do anything, any more configuration or anything more. It's just, you can just start those volumes from the cluster itself. And there was some GitHub link. Okay, it was the Cinder driver. So
yeah, so Cinder CSI plugin, that's what I was presenting today for the Postgres persistence.
moment. Does anyone have any more questions? So if not, because we are out of time, from my point, one more thing to remember is that one more question. Can you mount your data in pods? Yes, it's mounted when you select your data as an option when you start the cluster. So it is already there. You don't have to access your data through S3. I think so. So there is no need for Boto3. Yes, Paweł, is this correct?
Actually, I would need to check. I would need to check and maybe get back about this. It's a matter of just going to the pod and checking.
Okay, can we do this? I don't know now, or we'll send the answers later.
I think I would send the answer later, unless I.
Okay, we'll send you the answer. So the next question is: can the user upgrade the Kubernetes version? So currently there is no. You just have to deploy the cluster with a newer version. There is no upgrade process. There is some work being done on this because we know that upgrading cluster is usually very important for users. So there is development works going on, and we'll get this feature at some point in time, but there is no roadmap for it yet. So firstly, as I heard from the Kubernetes team, we'll adding the support for more Kubernetes versions, and then later we'll do the upgrading procedure. But from my experience, it's if you are doing the computation on the cluster, not presenting the some things to the general public, it is usually better to just set up the new cluster. So one more important thing from me is that this, when you set up this Kubernetes cluster as Paweł did, now it's the whole tool is free basically. So you are paying only for the resources you are using. So for VMs, for IP addresses, load balancers, and so on. But you are, because those are the computing resources, disks, and so on and so forth. But you are not paying for the tools and cluster itself, only the resources.
Back on the question, so I did verify. I have not seen the EO data on one of the pods, but I would need to verify if I'm actually using the one that I've configured for using the EO data. So I will need to get back on that.
Yeah, but I think it's an important feature, so we'll get to the team to add this if it removes some pains from the customer part. Okay, so Paweł, any last words, because we are already 10 minutes behind schedule?
No, thank you very much, everyone, for attending. It was my pleasure to be presenting for you today. Thanks a lot for your attendance.
So thank you very much, and if you have any questions, please email us or reach to our sales guy. So thank you very much, and
thank you.
See you soon on the next webinar.
Bye-bye.